And welcome to this webinar on artificial intelligence, which we call basically a primer on artificial intelligence, right? Over to you, Dipit. You'll start with the introduction.
Right. Thank you, Ashish. Thank you. So good evening, everyone. And on behalf of FirstUniv, I'd like to welcome you all to our first of many webinars, hopefully. And today's session is around machine learning and artificial intelligence. You know, we, of course, have heard of these terms. A few of us have surface knowledge about these technologies. But a lot of us actually don't realize how much of our life actually revolves, around these technologies. And that is something that we will talk about today. My name is Dipit Sharma. I'm the Director for Alliances and Partnerships at FirstUniv and your moderator for today's session. We will open the floor for Q&A after every session. And of course, I would request you all to type your questions in the chat box as we go. And I also like to introduce our two experts, our two panelists. We've got Dr. Kushal Kanwar, a PhD from Punjab University. He also has qualified for GATE and UGC NET. Dr. Kushal has been teaching for many years now and has helped countless students, pursue their ambitions through artificial intelligence under his mentorship and under his guidance. As an active researcher, Dr. Kushal has published papers in AI and a lot of complex systems. And we've got Mr. Ashish Khosla here as well.
Hi.
An engineer from PC Punjab, MBA from IIM Calcutta. Ashish has served in leadership roles across the world in companies like Citibank, HSBC, UNB. Ashish is also an angel investor and mentor for many tech-based startups around the world. And he also serves as the president for innovation and technology at Shoolini. And Ashish also is the director for the AI school at Shoolini. And Ashish also serves as the chief executive at Learnins /Aaddoo, which runs the FirstUniv platform. So welcome, gentlemen. Thank you so much for taking the time to join us today. And without further ado, I would like you to please initiate the session.
Thank you, Vipin. And
thank you.
Hi, Dr. Kushal. Yeah. So the way we'll structure it today is, and that's what Dr. Kushal and I were thinking, is that we'll structure it and divide it into three sessions. The first one would be why artificial intelligence, which is the same as saying, why follow a career in artificial intelligence? And the second is what? Basically, what is artificial intelligence? Even before you take a course, you need to know what is artificial intelligence broadly. And then how? How do you learn artificial intelligence? And we probably will take the example of Dr. Kushal or some of his students. How is it that they took the steps to be very successful and reach where they are in terms of being experts in artificial intelligence? And what can we learn from all this in terms of quickly climbing the same steps? So without much ado, let's go to the first question. And I'm sure a lot of you guys probably know this, but the thought is, what exactly is artificial intelligence, And the answer to that is quite simple, and we see it around us in so many examples, maybe be it self-driving cars, be it the basic robots that have come out. Even when you do a Google search, what is AI is when a computer and a machine can learn, when it can think, and when it can communicate. And basically, when it can even do what human beings with all their intelligence can do. And that essentially is artificial intelligence. Yeah. And coming to what areas around us, what businesses, what industries need artificial intelligence, and we are making a list. And these are some of the areas where our team at Shoolini has actually worked in already. And it is medicine, a lot of work happening in medicine. Even the fact that they were able to crack RT-PCR in a few months rather than a few years. And then finally, when they came out with the new ways of coming out with vaccines, largely driven by AI. Engineering is full of examples of AI being used in companies, telecom in a very big way. Banking and fintech is a very large consumer of AI. Myself have, coming from banks and their teams, which are looking at how to implement AI across the platform of a bank, be it in sales, be it in retail, be it in corporate banking. Yeah. Uh, Things like graphic artists also, and there is an example of a 19-year-old boy who sold a painting which he created with the help of an AI, which sold for $350,000. In education, we are beginning to use it very effectively. In fact, if we have time, we'll talk about one of our applications called Sikandar.ai, which incidentally was designed by students from Shoolini and is doing pretty well in terms of its ability to get in clients and use them in AI, and then managers and in gaming as well. And that gaming is where actually it all started out. We have a question. We'll take your question at the end of this session. Right, Dr. Kushal?
Yes.
Right. We'll take but we'll just quickly close this first session because people would want to know, why should we study AI? And the thing is, it's the technology of the future. As we saw in the previous slide, there is not a single area that's not being impacted by AI. And there was a survey done by Glassdoor which said 70% of all the companies in the world, will run some program linked to AI in the next 3 years, which basically means that there will be millions and millions of jobs across the world for people who know AI, machine learning, data science, data analysis. And that is an opportunity for students from India to grab. So currently, if you look at it, the entry-level jobs are between, I'd say, around maybe 5-6 lakhs to 11-12 lakhs when you start out. A mid-level role at between 3 to 8 years. And Dr. Kushal, you have quite a few students in this range, right?
Yes.
And what's the range there, Dr. Kushal?
Like at entry level, people start like 50 to 50,000 per month, and slowly they start growing as with the experience. And some are at middle level; they are earning very good. So, and we had to see some
15 to 30 lakhs, right?
Yes.
True. And when you come to the senior level, which is probably 9 to 14, 15 years and above, and I don't think actually there's anybody with more than 10 years of work ex in AI, right? And that's around 50 lakhs plus. Yeah, so that's the interesting thing. Unlike a lot of other areas where you have people with huge years of experience, this is a relatively young industry. And yesterday I was also doing this search on Naukri.com, and I said, let me see how many AI ML jobs are there on Naukri.com. It was the second highest area in terms of openings. Yeah, and that's in software. So interestingly, not only is it better paying, it also has lots of openings. So there were 3,628, 36,000 openings in AI and ML. Yeah, so that's the broad range of salaries. And what are the careers you can follow? And as you move on and develop a career in AI and ML, you see that you can actually specialize in one of these areas. You can be a machine learning researcher. You can be an AI engineer. You can be AI software engineer. You can do data mining and analysis. You can be a machine learning software engineer. You can be a data scientist, which is a bit, slightly different from being a hardcore AI career software professional. You can even be a BI developer, which again comes from being a data scientist. And maybe if you have time or if you have a question, we can tell you what kind of job tracks a data scientist follows and an AI and ML software engineer follows, or a software professional follows, and what you can do if you want to follow either of these, and what are strengths that you need to have to do either of these, right? So I think that's the first session, right? And the first session is, this is an area that is growing. This is an area which has young professionals right at the top, right? Dr. Kushal has been teaching for what, 6-7 years AI, Dr. Kushal?
Like, sir, more than 5 years, 5+
More than
years.
5 years. And, you've seen huge number. When you started out, probably you had fewer students, but now you have a large pool of students coming in, right?
Yes, sir.
Okay, so we'll take any questions if we have, Dipit, if there are any questions there at this stage.
None yet, Ashish.
Somebody had raised his hand at one point of time.
Right. I can't seem to find that. Okay, I don't think I can see that.
If there are
To
any
whoever,
questions on this, any clarifications you need, please type it in and we can take that. Okay.
Thanks.
thank you.
We will now move to the next part of this presentation, which is what is AI? And when you look at AI, to be very frank, and that's the image that comes to our mind. And these are, on the bottom you've got this Terminator robot, right? It's out to kill the world. And at the top there is this robot, an iRobot, who's trying to save a lot of people. The point I'm trying to make is this is called general AI, which is an AI which is able to do everything end to end what a human being can do. The issue here is that technology has not reached a level yet. Maybe one of you at a later date would work on something that is general AI, but as of now, AI is at a very different level where we can't reproduce the end-to-end experience of being a human being. So what you currently have is what is called specialized AI, but essentially what we're trying to say is that general AI is incredibly hard. The human brain, you've got billions of neurons and a lot of special and general functions, and it works in ways which we haven't even understand. Forget about copying it. So we're so far behind from nature that we don't have general purpose AI as of now. What we do have is special purpose AI. And what exactly do you call special purpose AI in your scientific lingo, Dr. Kushal?
Yes, sir.
What is it called?
Special purpose AI, we call it at narrow intelligence.
That's right. This is narrow use AI, right?
Yes, sir.
So
this is the AI which works for a particular thing very well.
Exactly. So you have AI that works on a particular thing. So you focus on one area. So that's the whole point. These days AI can focus on one area and do it very well. So you may have an AI which plays games, so it can only play games. So Mohsin Khan has raised his hand. Mohsin, you want to type in your question?
There was a student, there is Swati. She asked, do we need to be genius to start learning AI? So I want to say, no, you need not to be a genius to start learning AI. You just need some very basic background in statistics, computer science, and linear algebra, very basic. And you have to learn some Python, and with this you can start your journey. So anybody can learn AI if he has some background in a little background, small background in mathematics, and learn some Python, and you can start doing it. And we are here to help you.
That's a good point. In fact, Dr. Kushal, if if I'm reminded on this, when I was younger, maybe your age or maybe even younger, and I was in engineering college and I'm in Calcutta as well, to write a program meant you had to write 20,000 lines of code to come out with a serious program.
Yes.
Yeah, because that was the way it was. But today, you can write a program by writing an AI program can be written by writing 100 lines of code, right? Because it's not about the code, it's about the data behind the code. So these days they say data is gold. So it's not about the code, it's about understanding that particular area, that business, that game, right? And then using that data.
Yes.
And then writing the basic code, because who's doing the thinking here? Who's doing the model, the thinking? Quote unquote, the thinking is done by the AI, right?
So I want to add one point here. So for example, we have very basic algorithms in AI. Very first algorithms we learn, that is known as linear regression techniques. Okay.
Yeah.
So the code of linear regression, in 10 lines, you can come up with a very good program. Okay. Because most of the stuff is already built. You have to understand the thing and then you have to just play with it. Okay. So you need not to write a lot of code by yourself. You need to understand what is already there and how to play with it. So,
yeah, but if I may add to that, you should have a lot of practice in working with examples and projects. That's how you learn, right? It's not about being a genius. It's not about writing a lot of code. It's about getting practice, getting more familiar. What are the models you want to run? If there's an error on the model, for example, we were working on a model which captures the emotion when you smile or when you're frowning, right? It's about what models you run, how do you capture errors, how do you treat errors, how do you treat cases which are totally different, right? So those are the kind of things that you need to build. And for example, Amazon, when they came out with their first time they started hiring, they rejected all women and they rejected all Black people. Why? Because the data they had of successful Amazon engineers was of white people in the US. So when somebody pointed it out, they stopped their recruiting program and fed data on women and differently colored people. And then they came out with a better program. Yeah, so we have another question there, do we?
Yes, sir. There is a question by the winner. Can you please describe difference between AI, machine learning, and data science?
I think that will come on later. And there's another Pragati saying that I pursued my bachelor's in commerce and I'm doing my MA. Can I pursue this program? To be frank, Pragati, we'll take a test, right, Dr. Kushal?
Yes, sir. Yes, sir.
So
Pragati, I want to add one thing here. If you have like understanding of like 12th class mathematics, then you can take it. Then we can take you further. If you know this much of mathematics, we can take you further.
Okay. So the point here is that our program comes with a promise, right? Yes. Our program, right? Promise is to help you make a career, and we'll take a basic test. If you qualify that test, we're pretty confident we'll help you build this career. Right? Coming back to special purpose AI, the program that plays chess can only play chess. It can't play Go or poker. The program that can drive cars can only drive a car. It cannot say hello to you. So this is special purpose AI, only written for one purpose. Yeah, Dr. Kushal?
Yes, sir. And so Devinder is asking, should we answer his question right now?
I think automatically that comes up later. So we'll take it up later. Right? So I think you are talking about the difference between AI, ML, and deep learning later on, right? That's a good question, Devinder. Huh? Thank you. So some other area. So, for example, today I was actually at a hospital and they were trying to use VR, which is virtual reality, and AI to help doctors screen patients faster. So there I can only do one thing, which is just look at that record and screen patients of one type and do that faster. Now I'm going to talk about gaming because, actually gaming is something that interests a lot of students, and it's also linked to the history of AI because the gaming cards that came out actually gave computers the power to process AI. But in gaming is where there's been a huge amount of leaps and bounds in how AI has come up. And, Watson defeated the Jeopardy champion. Jeopardy is a game. It's very difficult to understand, pretty complicated. Of course, people used to think before 2010, 2011 that nobody can beat the world champions. IBM Watson, which is a program run by IBM, the same IBM, by the way, which will be on your certificate, their IBM Watson, and you'll use IBM Watson also, defeated the world Jeopardy champions. And then 2015, DeepMind defeated all the Atari games. If you played those video games, AI beat everybody. And then there is a game called Go. It's a Chinese-based game. It is linked to chance and logic and strategy. And people said, AI can beat people in chess and Watson and Jeopardy, but they can never beat the world champion in Go. But AlphaGo in 2016 defeated the world champion 4-3. And after that, nobody's been able to stand up to AlphaGo or AI. So it's been, AI has consistently been able to outperform human beings when it comes to rule-based games, right? But then, what about poker? Poker is 80% chance. So, पहले लोग बोलते थे कि ये सब हो गया है, but AI will never beat human beings in poker. But 2017, CMU, which is Carnegie Mellon University, they made a program called Librettos, and that defeated the world champion for poker. So basically, it's AI being better off than human beings, and I'll tell you under what circumstances and conditions, but in all kind of games that were linked to human intelligence at one point of time. But for me, the crossroad came in 1997, and 1996 actually. Garry Kasparov was the world champion of chess, and he played Deep Blue, and he won. And people like me said, yeah, of course, Garry Kasparov will win because he was supposedly the world's best player ever, and he'd beaten some of the very, very top-ranking players quite easily in very interesting games. And of course, what is it for him to beat a computer? In 1996, so he won, but look at him in 1997 in his third game when he's losing it. and he knows you couldn't have played that game at all. So these days, you don't even play against computers. You won't hear of Gary Kasparov or Vishwanathan Anand trying to challenge a computer at all. And let me tell you why. And maybe you'll understand how computers work. So, I myself play a fair bit of chess, and, small college PEC, not many students at that point of time. So I was a chess champion at my college. I have played a little bit here and there after that. So I started playing chess around 6-7 years back. I started doing pretty well against human players, right? No issues there. And then suddenly one day what happened was I said, let me start challenging these computers. So there's this program called Stockfish. I play against Stockfish and I lose. Again, I play, I lose. I just kept losing. And I said, what is the reason for that? So let's look at the reason, So I'm taking a chess situation here. And in this chess situation, I'm black and I can play in 25 ways. And if the computer is on the other side, it can also give me a response in 25 ways, right? So the question here is, if I want to think 10 moves deep, which is probably what Gary Kasparov does, how many moves will I have to analyze? But forget 10, because Stockfish analyzes 25 moves deep, which means it thinks of the next 25 moves. So how many moves would I have to think of if I think 25 moves deep? And let me tell you the answer. The answer is, if I want to think 10 moves deep, I will have to think of this 95 and this huge number with lots of zeros ahead. It's 95 billion moves. Okay, there's no way I can remember that. Now, people like world champions, they have a way of looking at strategy and finding out 10 moves deep, what is the best move to play. But I cannot, and that's why I get defeated by Stockfish. Now, but let's look at 25 moves deep. Now, here what is happening is, it is 8 billion, with a number is like most stars in the galaxy, right? There's no way I can play against that. And there's no way Gary Kasparov can play against that. And that is why computers win. And by the way these computers work is, when you first play against a new bot, a new AI that starts playing chess, you will win, right? But the more that AI plays, the better it starts getting, so it builds on the model slowly. It also starts playing with itself and gets better and better and better. It gets so good finally that no human being can play against it. And that is how AI works. It works on data. So this Stockfish is working on the data of all games ever played, right? So you can't defeat it. Dr. Kushal, you want to add to that?
Yes, sir. So actually how it happens is that the model of AI is very big. It has many parameters. So as you start playing with it, so it is not trained. So when you start playing with it, it gets training in iterations, and its parameters gets more and more correct weight on it. Okay, so that's how it learns. So once AI plays like 5, 7, 10 games, so it starts performing good, and ultimately when it reaches like 100 games, so it is undefeatable. You won't be able to defeat it.
Exactly. So it's parameter training. It's not a very complicated program, but they fed a lot of data, and the data is games, right? Now here's a question. I'm not sure we can do questions there. Can we do polls there? I'm just wondering, Dipit.
I think we'll have to check with Hemant.
Hemant, can we run a poll, or should we skip this and we'll talk about Alan Turing? Alan Turing is, he's a genius. Can we run a poll, Hemant, or should we skip the poll?
Yeah, we can run a poll, sir.
Why don't you run this poll? Yeah, let's get our participants to participate in the poll. So if you've heard of Alan Turing, and maybe you've heard of a movie called Imitation Games, where that's right, Dr. Kushal, which is on his life and what he did at a certain period of time. So if you can run the poll, the question is, try to type A, B, C, D when the poll comes in. So Alan Turing, A, was the scientist who invented the first AI program that beat Gary Kasparov in chess. He invented the world's first computer that could run an AI program. He wrote a rule to identify if a software could be called intelligent. Or D, he wrote the world's first AI program. Now, if you can't see the poll, can you just write your answer in the chat? That'll be good enough, right? What do you say, Hemant?
Yes.
So why don't you just write your answer in the chat and let's see if somebody wants to answer. Don't worry. So Swati is saying B. Ashish Sharma, just write your answer in the chat. So Swati says he's a person who invented the world's first computer. Any other takers on this?
C. Devinder is saying C.
Devinder is saying C, okay.
Rohit is right. He decoded the Enigma code.
Enigma, but which one of these three, Rohit? Yeah, you've seen the movie, but which of these three? Yeah. Any other takers there? Abhishek is saying C. He's following Devinder. Okay, one more answer, then I'll reveal the answer to you. Somebody else is saying Pragati also says C. Okay, cool. So I think we'll the answer actually is C. You know, he wrote a rule, very interesting rule. A rule which tells you, which can be used to test whether a software can be called intelligent. And he wrote this rule in 1940. And today the year is like 80 years from there, and we still haven't been able to successfully break Alan Turing's rule. Let me tell you about his rule. He said, very simply, human beings are intelligent. Okay? To be called intelligent, a machine must produce responses that cannot be differentiated from that of a human being. Simple rule, right? So what he said is that imagine there is a room and the room is locked, and you're sitting outside the room and you send a piece of paper and an answer comes back. And you think there's a human being inside the room based on the quality of the answer, but actually it's a computer. You know, and then you can say that computer is truly artificially intelligent, right? Intelligent. So that rule was made in 1940, and that's a Turing test. Consistently, no computer has been able to, beat that test.
Okay,
and the reason is that
I want to add something here. So
yeah.
There are many variations of Turing test, and some of the students may go and read on the net, so they may find different variation of Turing test. So sir is talking about original Turing test. So these are the rules, and the original duration was like 5 minutes. For 5 minutes, and for the 30% of the time, the computer has to fool the human that it is human. Then we can say this machine is intelligent. So this was the basic criteria. Now it has evolved into many variations, Turing test. But the basic setup is same, that there is a computer and human logged inside a room, and you are outside a room.
That's right, Kushal. Thanks. Annually there is a prize called the Lebner Prize that is run, but it's $1 million every year given to the person whose AI is the closest to beating the Turing test. And when you do fool the people on the Turing test, it's something called the Chinese room fallacy. We will not talk about it here. We'll talk about it when you come to the course, because that's quite interesting, you know, that without knowing what you're doing, you can do something. And that's what AI seems to be doing. But coming back to the task at hand, another question here, and we'll skip this, but, you know, essentially AI is when it seems a program can appear to behave like human beings, and that's what AI is. If it can apparently behave means think, act, do. There's nothing like thinking, but act or do like human beings, and that's when a software program can be called artificially intelligent. We'll skip this. It's about Google plans. I do show it to younger students. It's about a Google April Fool Day joke that they made in 2018, right, Dr. Kushal? Yeah. But the funny part is that 3-4 years down the line, you know, they said you can talk to your tulip and the tulip will talk back to you. The funny part is that in the next 3 years, there have been so many articles, research articles on AI where some kind of a response and communication has been done with plants and roots or even animals. So looks like what is a joke today becomes reality 5 years down the line. That is how fast technology is actually working. And you all heard of Elon Musk, right? He's actually put a chip in a monkey's brain, which uses AI to read the monkey's action. So now the monkey is able to play a video game with its mind. Yeah. So so that's the level of stuff that is happening in the world in AI these days. So I think Swati or Pragati today, they asked this question, and I would like to ask a question back to you after this one. That what do you think? Which one of these are AI? Is it Is A an AI? It runs on rules which are coded. For example, you need 12 million lines of code for that. Is that AI? Or there are no rules, only examples and data, and you need 1 million examples, and you make a model out of it. And it could even be maybe 50 to 100 lines of code. So which one of these two is AI when you come to software coding?
Yes, please. Can you guess? Can you people guess? This
Put
is
in
very
the chat,
simple.
yeah, A or B.
Devinder is saying B. Okay.
Okay.
Other people, yeah, you can guess. Always guess, please.
Swati
Try to guess.
B, that's fine. Okay, yeah, the answer, I think we got 2-3 answers around B, and that's the right answer, right?
That's right.
So we've already talked about this. Very fewer lines of code, more data, more examples, and that is how AI runs. And here is a question that somebody wanted to know, I think, Devinder, what's the difference between AI, ML, and deep learning? Over to you, Dr. Kushal.
Okay, so whoever was asking this question, I think Devinder. So AI, artificial intelligence, is a broader domain. Okay, so there are many things like symbolic AI, connectionist AI, and many stuff. Rule-based system are there, and then comes the machine learning, which is more and more data dependent. Okay, so this is a subdomain of artificial intelligence is a bigger set. Machine learning is a subset of AI, and after that, deep learning is a further subset of machine learning. In deep learning, we talk about neural network and its variants, whereas in machine learning, we have like these decision trees are there, logistic regression is there, linear regression is there, such kind of algorithms are there. So the difference between machine learning and deep learning is that of neural network. In deep learning, we use neural network, whereas in machine learning, we use other data-dependent algorithms. And AI is the artificial intelligence is an umbrella term which covers all these things plus some rule-based system and some symbolic AI and stuff. Okay, and the other thing, what is the difference in data science? Data science is a domain in itself. Okay, separate domain in itself, where deep learning and machine learning finds a lots of application. So if you're a data scientist, you are doing clustering, classification, so you can use traditional techniques as well as the techniques from machine learning and deep learning. So that is the difference. So I hope it is clear. If you have a question, please ask a follow-up question if there is a doubt.
So thanks, Dr. Kushal. So AI is a concept, that came up in the 1950s, where they said, if there is any computer that can do intelligent stuff, that's AI. But then the whole thing about computers, the languages came up, and that came up in the 1980s. And that's machine learning, specifically using rules within computers and algorithms within computers. And then in the 2010s came this deep learning, these new techniques around CNN, ANN, which we'll talk to you about, which use neural networks. And that is deep learning, which try to propagate a network of knowledge and faster implementation of rules, so that computers can come out to some understanding of the context faster. So it's very new. It's only 10 years old, right? Deep learning, neural networks are only 10 years old. Still a lot of experimentation going on here. Somebody can come in and really crack it today. Okay, and Dr. Kushal, you want to talk about this, or should I? This is the example of. So this is an example between, of what is happening in medicine. So, and this example was given to me by a researcher in a university. He said, let me give you an example. He said, if you want to make a dermatologist is a doctor who does skin, who cures skin diseases. So he says, it takes 10 years to become a good dermatologist. Yeah. And the dermatologist will read all the books so many times, He said, compared to that, but he'll only look at one picture at a time, right? That's all he needs to do. And 10 years of experience, he'll become a good dermatologist. On the other hand, if you can show 120,000 samples to a computer, which has an AI program in it, yeah, it will become the equivalent of an AI for medicine, right? And the point is that, they've been tests done on that. They've seen that this computer, and it takes one day, by the way. So you can create 120,000 samples, give it a computer. Computer can become an AI for medicine or dermatology in a single day, right?
Or even faster if the GPUs are faster.
If
even
you have
faster.
GPUs like Dr. Kushal runs, then you can probably run it even faster, right? Yeah, you can run it on AWS, right? You consume a lot of
Google Colab.
Yeah, you consume your $3,000 every hour, right? You can do it much faster, right, Dr. Kushal? Yeah.
Yes.
So you can do it faster. So you can, from zero, you can make a doctor and get the person up and going. Yeah. The question that will come up, of course, is how many times was a doctor right and how many times was a computer right? And that's a little bit of a debate because there's an ethical issue also around AI, and that's a big issue that is coming up. People are probing that. People are seeing what to do going forward. And that is something that we don't have an answer to as of now. But importantly, what you need to understand is an AI can do with data in a single day or an hour. If you take Dr. Kushal's machine, what takes 10 years of human training to do, probably with the best human being at the other end. Okay, and Dr. Kushal talked about data science. Data science is slightly different from AI because AI is more focused on coding, and data science, which is Dr. Kushal is very passionate about that, is more linked to data, statistics, probability, discovering hidden patterns from raw data, right, Dr. Kushal?
Yes, sir. And this is a old field, not very new, that the industry and many experts are playing with the data for very long. And since machine learning techniques are good to handle big data, and from big data and large amount of data, they can predict, mine patterns and do predictions. So that's why the machine learning, whenever you hear data science, you automatically hear machine learning. That is the reason why these terms are coming together always.
Okay. Devinder has a question. Can we create an AI without deep learning, or is it application dependent? Dr. Kushal, you want to take that?
Yes, I want to take that. Let me read the question again. Can we create an AI without deep learning, or it is application dependent? See, there are many AIs which are not based on machine learning or deep learning. Like, for example, there is a program which is known as Prospector. So it is not based on machine learning or deep learning. Okay, so it depends. If you have like very good rules, you can frame out very good rules, then you can go for the rule-based system. So that is also a type of AI. But if you have like fewer amount of data but good quality data, that you can go for machine learning. But if you have huge amount of data, then you can further go into deep into the machine learning, deploy neural networks. Okay, so it is application dependent what kind of data you have available. So the main focus here is the data and quality of it. Okay, so that I hope that clarifies. And if you have any further question, please ask follow-up question.
Devinder, just to clarify what Dr. Kushal said, speech recognition came up even when we did not have deep learning.
Yes, right.
But if you notice that speech recognition did not really work. Very difficult to make it work. Yeah. In fact, I tried speech recognition in my college project in 1990 and 1991 or something. Yeah. And that point of time, even AI did not exist, right? We tried to frame the rules. So it's very difficult. With AI, it became slightly easier. So you got speech recognition initially when Siri was launched. It was done without deep learning. But now you have deep learning, right? And so,
yes.
On the fly, deep learning is trying to tell you what you spoke, right?
For example, you can do natural language translation. If you see Google Translate, so it is an example of deep learning. Okay, so they have deployed deep learning behind it. So now you can see you can do translation in real time, very quickly. Large amount of text you can translate. Even the speech can be processed. Like, for example, you may have seen the teleprompter at United Nations that a person is speaking in French, and it is automatically getting translated into German, Latin, and Spanish and other languages automatically. So that is happening because of the neural networks, faster neural networks.
So coming back, we can skip this actually. This is the history of AI. But the important part is this one, that this is the era of AI because you have faster machines. They can handle huge amounts of data, right? Sometimes you can use your own machine. Sometimes you can actually use the cloud to process data, right? So we got a tie-up with IBM, and IBM Watson processes data on the cloud. You don't even have to store it on your computer. You don't even need a hardcore fast computer because this is the era of machines, and machine capabilities there on the cloud, right? And if you can process more data, you can get AI to work. That is the fundamental aspect of AI. Data and process it fast, and use some basic rules to train it in a way that it can give you the right kind of answer that you want. Yeah. So now we come to this part, which is the ideal AI learner's journey. Over to you, Dr. Kushal, because you spend a lot of time here working on exactly how, when you start out learning AI, what are the 2 or 3 steps a person needs to do so that he can become a quote unquote Toru AI programmer in a short period of time?
Okay, so thank you, sir. So actually, what is it that you don't need to be very, very intelligent to do AI. Okay, so you need to learn this programming language, which is known as Python, and its syntax is very simple. And for example, if you just want to print something on the screen, you just have to write print and double quotes, write anything, it will print on the screen. There are libraries built. You have to learn very basic syntax, and it is easier than even R and MATLAB. I know all these three languages. Okay, I know Python, I know R, I know MATLAB. The Python is the most easiest of the stuff, and it is widely used, and it is very easy to learn. And you need to have some background, like 12th level mathematics. If you understand 12th level mathematics, so it is very easy for you to understand what is the meaning of this function written. Okay, so you need just this much of background. After that, with this background, you go for the machine learning fundamentals. You understand what is supervised learning, what is unsupervised learning, okay, what is semi-supervised learning. Okay, so you understand what is reinforcement learning, what about these things. You study some algorithm from each category. Okay, and after that, you choose your application domain. For example, if you want to work in NLP, you work in NLP. You like computer vision, or you want to do some research for the neural networks and deep learning itself. Okay, so when we talk about the neural network and deep learning, so there can be 2 things. Either you are applying these things, or you are refining these things. For example, there was many algorithms, like LSTM was there to process text, GRU was there to process text, but in in 2019, the transformer model came up. What is it? It is actually the enhancement of the previous models. You can do that thing, or you can use the existing models to solve some existing problem. For example, there is machine translation. Somebody is doing machine translation. It is taking, for example, like it is taking 3 seconds. You write your program in such a way and train your model that it takes 1 second, or you can do such stuffs. Okay, in computer vision, there are many things to do. Like you can make sense of some sense. Okay, video processing is one of automatic video processing. Many applications are there. You name it. Even we are using these applications as if we are talking. So what is happening that there is the voice lag when we speak. The data travels through the packet switching network. So the Zoom handles it with the help of these AI programs. Okay, so there are some modules behind. AI is already, unknowingly we are using AI actually. And the video quality adjustment, that is also done. And the alignment of the text, the speech and the video, it is done with the help of some programs. They use AI.
That's right. That's right. That's right. And there are many projects that we worked on, and these are some of the projects that we will get, which I think which are pretty interesting from a learner's point of view. What kind of programs can you start working on? So if you get data on, for example, images on cancer, right? You can build a neural network to predict the possibility of cancer based on image processing. And the tough part we've seen, and we had a student, she's not yet a PhD student. When she was in a master's, she went to hospitals, and that's in India, and kept asking them for more and more images to predict lung cancer. And she eventually was able to find it out. So if you get the images, either on the net or directly speaking to hospitals, you can write a program here. You can definitely recognize facial expressions, right, Dr. Kushal? That is something a lot of our students have been able to do.
Face recognition, emotion recognition, and
that's right. That's right. And I come from banking, and that's a big problem for banks. Is the loan good or is it bad? Is it likely to be good or is it likely to be bad? Should we give this person a credit card or not? Right? What kind of a limit or loan amount should we give to this person? So risk of loan analysis works very well with AI because you've got a lot of data there. Banks already have data. Feed it and come out with a good model for that. Speech to text, a lot of work happening here. Of course, Google's done a lot of work, but we also have a lot of local work around speech to text, around local dialects and local languages, which is unique. And still a lot of work can be done and projects can be built around that. Face recognition, be it on an individual or in a group. Again, those are projects that are interesting to start with. And lastly, and that's particularly since if you use something like IBM Watson, it's got a framework for building AI-based chatbots. And you can actually develop your own AI-driven chatbot and train it for a particular use, either in your classroom or your industry, or a basic simple website that you develop. So these are 6 or 7, these are 5 or 6 initial projects which help you get your hands dirty, so as to say, and immerse yourself in the world of machine learning and artificial intelligence. So initially you'll find some issues that you haven't been able to structure the data well. There are problems with data, you need to kind of fine tune that. But as you start doing more and more, by the second or third project, you realize what needs to be done. How do you get errors to be eliminated? How do you make sure the right kind of model fit is happening? You're not overtraining or undertraining or things like that. And that's by doing real projects is the only way. It's like driving, I can sit here and keep telling you that press a brake, press a clutch, press the accelerator, move the steering to the left when the road moves to the left, and right when the road moves to the right. But until you actually sit in a car and practice it, you won't be able to do that. Same for learning AI. It's about going and immersing yourself in 3 to 5 projects so that you get a hang of it. Of course, you do this while also or after getting the understanding of the basic logic of AI, which is what kind of model is involved, what kind of database do you need, what kind of errors do you need to look out for in specific. Dr. Kushal, you want to add to that?
Yes, sir. So if we talk about like some technical stuff like this, diagnostic cancer images is like a classification problem. Speech to text is a prediction problem, basically regression. And like you have AI chatbots. So first you predict, and after you have 3-4 prediction, like you type in some question you want to chat with the AI. It is going to do what it is going to do internally, what it is going to predict 3-4 sentences. After that, it is going to classify that which sentence is more appropriate to respond to. So this is how the things you learn, the classification, regression, and clustering, all these things will come up here, and this will summarize your knowledge of.
And to add to that, in risk of loan analysis, you can either have clustering. You also have supervised learning. It's a very good example of supervised learning, where you take existing data set where you already know the answer, whether the customer was good or bad after 6 months or 1 year. So you learn all these different techniques, and you don't need to stick to the same technique. You can try out different techniques and see what fits which one, particularly for more complex problems. Right? Next point is that, you do this AI ML with FirstUniv, with Shoolini University and IBM. You get 6 certifications from IBM and a final certificate from Shoolini University in partnership with IBM. It's important to see who's certifying you, whether 3 years down the line that certification will have value. More importantly than that, will it give you a leg up to be able to get your first job that you're looking for in the industry. So career support is very important. So you need to see that that not only are you able to learn more about AI, you're able to project it properly. You understand the key trends. What is it that the employer at the other side is looking at? By the way, we have something called AI interview coaching prep, which actually helps you prepare for AI-based interviews or general interviews also. And you build your e-portfolio, including a patent. So that's something unique that we built in, is that we've seen let people work in groups and form a process patent. And the cost of that patent is picked up by, in this case, FirstUniv. It helps you clearly distinguish yourself in that whole pool of people who are looking for those 32,000 jobs that we saw in Naukri.com. And while we're talking of this, one last thing, and I think that is something that I'm here to announce as well, is that since you are one of the founding batches of this particular certification, we give you a job placement guarantee, which means we are confident that you'll get a job, and we moved it up from being just a job interview guarantee to a placement guarantee. So if you are in your final year of graduation, or if you've graduated, the guarantee is that you will get a job after this program. If you are in your second or third or first years, the guarantee is that you will get a paid internship. So we're putting a lot of effort behind making sure that people who enter this program are ready to crack careers in the industry.
Okay, so there is a question by Swati. What are typical jobs related to AI? So sir is going to give you one example that what AI engineer does on the next slide only. Then I will elaborate. We will elaborate further.
So, typical jobs of AI are actually, building products, or if there's a product, building a model around a product, So I'll give you an example. Here is a program that is written by actually students of Shoolini University. It's called Sikandar for communications and job interviews. So what it does is, it looks at the way you look, your visual analysis. So, the camera opens and you speak and say for 3 minutes, it looks at your expressions and sees, are you smiling? Are you sad? What is your smile index? What is your posture? Are you standing straight? Were you bending, right? And overall, are you looking dull, or do you have a fair amount of variance? Just look at this aspect. So to make this, what they did was somebody looked at an existing open source program that was available, but of course it was not working properly, right? They then pulled a lot of data from one side and fed it to the computer. The computer gave some responses, and they looked whether this response was in line with the kind of response. So if the computer said smiling and the guy was looking like this, they realized there was some mistake, so they marked that separately. So they looked at that data, they reanalyzed the data, and for each one of these points, there was a separate model that was built. So they built a model for expressions, or for smile index, for posture, and variance, and they all pulled it together. So the whole thing was they took open source programs. Based on that, they made some of their own programs. They kept feeding data, fine-tuned the data, looked at errors, revised the program based on errors, till they came with something which was acceptable in real life. So that is a typical role of an AI engineer, which is to work on the model, to see where the errors are, to look at the data. Often you work as a team, you're given one small part, so one person could actually start by looking at the data only. The other person is the person who's looking at modifying the model, or looking at alternative models for the same program or the same project, to see which is the model that gives the right kind of final output. In a large team, in a small team, you might be looking at 2 or 3 functions on your own. So that's the kind of work an AI engineer or AI software professional does. Kushal?
Yes, sir. So, for example, you have to develop some some products. For example, somebody is developing something like Zoom. Okay, so they will give you one small module that whenever the video stream will come, you are going to filter it. You have to write a model to filter it. Okay, and like you have some speech to text product. Somebody is building a text editor and they need a spelling corrector, and your expertise is in NLP, so they will ask you to do so, like spelling correction and the correct word suggestion. These are the applications of NLP, natural language processing, or applications of AI. Okay, so such kind of stuff, like you see many applications around you, like even in web search, the AI is being deployed. So the AI engineer are doing a lot of such stuff, like retail analysis. For example, you are deployed in a company which works in retail, like Amazon. They want to, as you see recommendation on the Amazon, like the person who bought this also bought this. Okay, if you purchase these things, so it will be easier for you. We will give you 10% discount. Such kind of rules are framed by AI engineers. Okay, so our domain experts is going to sit with you, and you're going to do such stuff.
Great. So I think that's all this answer, and we're almost at the end of our time, and we are at the last slide. Right, and the last slide is here's wishing you all the best for your career in AI and ML, right? I hope that you take this course or some other equivalent course, which motivates you gives you the right kind of training, the right kind of projects to work on, the right kind of teachers who will teach you, and the right certificates. But most of all, that placement guarantee that helps you make sure that you are entered into an area that you really want to enter. Yeah. So that's all from us. Thanks a lot. If you still have any question, we can take the last question because we are still within a bit of time. So any last question we'll take.
Thank you, Dr. Kushal, and thank you, Ashish, for that very, very insightful session. And to all our attendees, thank you so much for taking out the time to attend today. And I think we've got some questions, but I believe we have answered all of them. If you do have any more questions, I think now is the time that you could use the chat box. Alternatively, our team would be in touch with you, and we would love to hear your thoughts and your feedback on this session and how we could further improve our offerings. So I think I'm just going to wait for one more minute before we close out the session. If there are any questions, please do let us know.
Right. So by the way, talking about questions, I think, Dr. Kushal has written a program, yeah, where at the end of a class, automatically 20 questions are asked. Right, Dr. Kushal? Yeah.
So that is known as MCQ generation. And
then it creates, and then you have to answer them, right? So it asks 20 questions and with 4 MCQs to choose from, right? Yes. So yes, they're just about answering questions and asking questions. AI is going to come up in the next